Hi everybody, welcome to our second lesson in Unit 12. Today we're going to be talking about multiplying radicals. This is also going to be our very last lesson for the school year, so that's exciting. So to multiply square roots, what we're going to do first is multiply any numbers that we have outside of the two radicals. Next, we're going to multiply the two numbers that are both inside the radicals. And then we're going to follow the steps from the last lesson and we're going to simplify the radical. So for number 1, we're multiplying 5 times the square root of 3 times 2 times the square root of 6. So the numbers outside of the radicals are 5 and 2. So I'm going to multiply them together to get 10. Then I'm going to put a radical sign, and then I'm going to take the numbers inside the radicals, which are 3 and 6, and I'm going to multiply them together. 3 times 6 gives me 18, and that product is going to go inside the radical. So those are the first two steps here. Next, we're going to simplify the radical like we were doing in our first lesson. That's when I try to find all of the prime factors of the number inside the radical. So 18 is even, so I know that I can multiply it by 2. So 18 divided by 2 is going to give me 9, where 2 is prime. 9 is not even, but I do know it's divisible by 3. 3 times 3 gets me 9. So the prime factorization of 18 is going to be 2 times 3 times 3. And then once we write the prime factorization, we find pairs, a set of 2, of the same factor. So I have 2 3s. We're going to bring one of those factors outside the radical, and then inside the radical they go away. So I'm going to bring, I have the 10 outside, that's not going anywhere. But now I have to bring a 3 outside. I'm going to write the radical symbol, and what is the only number I have left under the radical? That's 2. When we bring a number out in front of the radical and there's already a number, or we're bringing multiple numbers out in front, we always multiply them. So 10 times 3 is going to get me 30 times the square root of 2. So I would like you to write your final answers with a single number in front and a single number in the radical if there is one. So let's try another one. We have the square root of 5 times the square root of 15. So technically in front, there's a 1 and a 1, not 0 and 0. So 1 times 1 would just get me a 1 in front. We don't really have to write the 1 in front, but if you want to, you can. So inside the radical, I'm going to multiply 5 by 15, which is going to get me 75. So I'm going to start to think about prime factors of 75. Well, I know 75 is not even, so I'm not going to divide it by 2. I know if I try dividing it by 3, I get a whole number. So 3 times 25 gets me 75. Well, I know that 25 is divisible by 5. 5 times 5 gets me 25. So I have my prime factors. I'm not going to write the 1 in front anymore because I don't really need to write it. So the prime factorization of 75 is 3 times 5 times 5. Find a set of 2 of the same factor. So I have a 5 and a 5. I'm going to bring one of those numbers out in front, and then the group inside goes away. So a 5 is going to come in front of the radical. The 5 times 5 goes away inside, and I still have a 3 left. So 5 times the square root of 3 is going to be my final answer. I have a single number in front and a single number inside. All right, moving on to number 3. We have a -7 in front and then nothing in front. Technically, there's a 1 here. So -7 times 1 is still -7. Inside the radical, we need to multiply the two numbers. The two numbers we have are 14 and 8. So if we multiply 14 by 8, use the calculator if you need to, we're going to get 112. So now, I know this is a bigger number, but we are going to just kind of go through the same process of figuring out the prime factors. 112 is even. So first thing I'm going to do is multiply it by 2. Or divide it by 2, excuse me. If we divide 112 by 2, we get 56, which is also even. So if we divide it by 2, we're going to get 28, which is also even. 28 divided by 2 is 14, which is also even. And if we if we divide 14 by 2, we're going to get 7. So the prime factorization, I'm going to write the -7 out in front. The prime factorization of 112, I have 1, 2, 3, 4 2's. And then a 7. So I almost forgot to write it, but I did keep the number in front, -7's in front, and then the prime factorization of 112 underneath the radical. And then we're going to simplify. So we need to find groups of 2 of the same factor. So I have 2 2's. I also have another group of 2 2's though. So in each group, I'm going to bring one of those numbers in front, and then the group inside is going to go away. So what do I have out front? I still have a -7. From the first group, I have to bring a 2. But also from the second group, I also have to bring another 2. What do we have left in the radical? Just 7. But now we have to multiply all these 3 numbers together. Well, -7 times the first 2 would get me -14. What's -14 times the last 2? That's going to give me -28 times the square root of 7. The last one says the square root of 12 times the square root of 12. So technically I have a 1 and a 1 in front. So in front of the radical is just going to be a 1, but I don't really need to write it, so I'm not going to. 12 times 12 in the radical, use the calculator if you need to, is 144. Now, if we take the square root of 144, if we did that in the calculator, we would get 12. So there's really a shortcut that I want to go through. Instead of thinking of the prime factorization of 144, 144 is larger than 112, and 112 we had to do all this work to get the prime factorization. So there is a shortcut, and I want to go through that. The shortcut is that whenever we're multiplying radicals together that have the same exact number under the radical, like here I have the square root of 10 times the square root of 10. The answer is just going to be that number under the radical without a radical symbol, 10. If we multiplied 10 times 10 would be 100 under the radical, and 100 is a perfect square. So you take the square root, you get 10. We could also do other numbers. Like if I did square root of 9 times the square root of 9, under the radical I would get 81, which is a perfect square, which would give me 9. So notice that the answer is going to be this number under the radical without the radical symbol if you're multiplying the same exact radicals together. So if I were going to take, for example, the square root of 51 times the square root of 51, I don't actually want to pick up my calculator and figure out what 51 times 51 is. But I know using this shortcut, if I'm multiplying the same radical together, the answer is just going to be this number under the radical without the radical symbol. Maybe one more. If I were to take 1,234, the square root of that, times the square root of 1,234. Again, I don't want to pick up my calculator and figure out what those two numbers multiplied together are. I know this shortcut. Whenever I multiply a radical by itself, I'm going to get the number under the radical with no radical symbol. So that is a shortcut.